5.1 Fundamental Identities. Alright, so we obviously did some stuff with this last year in Algebra 2, or college algebra, but I'm just going to kind of jump back in to this stuff. So you should have had all your identities in your notes. You're going to need those to refer to as you do this stuff, because we're going to be simplifying things like as much as possible. So 10 cotangent of x times the tangent of x. And I'm going to tell you, like, I'm sure I said this last year, but, like, there's different ways that I can, like, do this. Like, I can, with cotangent, I can write it as cosine over sine. Tangent, I can write as sine over cosine. I could cancel it that way. I could also rewrite cotangent as 1 over tangent. So it's really just up to you how you want to do it, but doing it that way would be less writing. So 1 over tangent of x times tangent of x. Those things cancel, and I'm left with 1. Um, 12 cotangent of u times the sine of u. And you can change the variable that they're using if you prefer something different, but I'm choosing what they're using. So what can I rewrite in this one?
Make cotangent cosine over sine.
Yep, I can rewrite cotangent as cosine over sine. So then sines cancel, and I'm left with cosine of u. (16) Sine squared of u plus tangent squared of u plus cosine squared of u over secant of u. So whenever I see stuff squared, what identity should I think of? Yep, the Pythagorean identities. So on the top, is there anything that I can combine to write as something else?
Sine squared plus cosine squared equals 1.
Yep. So I can rewrite this as 1 plus tangent squared of u over secant of u. And what's 1 plus tangent squared? Secant squared, so secant squared of u over secant of u just is equal to secant of u. The next one say to simplify to where it's either equal to 1 or negative 1. So secant of negative x times the cosine of negative x. These are the odd and even identities. So what happens to these ones?
Maybe secant cosine.
Yep. So the negatives just go away completely with these ones. So secant of x times the cosine of x. And then is there something I can rewrite?
Make secant 1 over cosine.
Yep. 1 over cosine times cosine. Everything cancels and I'm left with 1. Keeps making these boxes crooked. What's going on? Okay. 22. Secant squared of negative x minus tangent squared of x. So the secant squared of negative x, the negative just obviously for secant goes away. So I've got secant squared of x minus tangent squared of x. So again, I'm thinking Pythagorean identities. Is there one that I can manipulate to do secant squared minus tangent squared?
Secant squared of x equals 1 plus tangent squared of x.
Yeah, so secant squared is equal to 1 plus tangent squared. So I can move that over. So secant squared minus tangent squared would just be equal to 1. Let's see, simplify to either a constant or a basic trig function. So 24, 1 plus tangent of x over 1 plus cotangent of x. So obviously nothing I can like see right away that's going to cancel. So what I would recommend is rewriting in terms of like sine and cosine first. So this is 1 plus sine x over cosine x all over 1 plus cosine x over sine x. Any idea what I might need to do now? What happens when I try to just like add the top together? What do I need to do to be able to do that? Common denominator. So I'm going to multiply this one by cosine over cosine. This one down here by sine over sine. So when I do that, I've got cosine x plus sine x over cosine squared of x all over sine of x plus cosine of x over sine squared of x. What happens when I have a fraction divided by a fraction? By what? Yep, keep, change, flip. So cosine x plus sine x over cosine squared of x times sine squared of x over sine x plus cosine x. So the cosine plus sine, obviously one's written that way and one's written as sine plus cosine, but those things cancel. So I'm left with sine squared over cosine squared. What would that be equal to? Yep, tangent squared. Let's see, 26. Secant squared minus tangent squared. Those are both of u, which it doesn't really end up making a difference, but anyways. Over on the bottom, cosine squared of v plus sine squared of v. So how can I rewrite the top? Yep, secant squared minus tangent squared would be 1. What about cosine squared plus sine squared?
1.
Yep, that's also 1. So this whole thing is just equal to 1. All right, the next one say use the basic identities to change the expression to one involving only sines and cosines. Then simplified to the basic trig functions. So they want everything rewritten as sine and cosine first, and then simplified. 28, sine of theta minus tangent of theta times cosine of theta plus cosine of pi over 2 minus theta. So they want me to rewrite everything in terms of sine and cosine first. So first thing I see I need to rewrite is tangent of theta, which is what in terms of sine and cosine?
Sine over cosine.
Yep. So sine theta over cosine theta times cosine theta. And then what about this cosine of pi over 2 minus theta? It's one of your cofunction identities.
Sine.
Yep, sine theta. So now I've got cosines here cancel. Sine minus sine plus sine is what?
Sine theta.
Yep, sine theta. Let's see, 32. Secant squared of x, cosecant squared of x, or sorry, hold on. Secant squared of x, cosecant of x over secant squared of x plus cosecant squared of x. So I've got to rewrite everything in terms of sine and cosine first. So this is going to become 1 over cosine squared of x times 1 over sine of x all over I was making sure that wasn't an identity. 1 over cosine squared of x plus 1 over sine squared of x. So that's the way it's rewritten first. Any ideas what I might need to do next? So I can't do that quite yet because I've got adding on the bottom, not multiplying. But ultimately I will do that. If I want to add 2 fractions, what do I need? Common denominator. So I'm going to multiply this one by sine squared and this one by cosine squared. So on the top, I've got the same stuff. I'm just going to rewrite this as 1 fraction on the top. So 1 over cosine squared x times sine of x all over on the bottom. Since I'm going to have a common denominator, I'm also going to write this as 1 fraction. So this is going to be sine squared of x plus cosine squared of x all over sine squared x cosine squared x. Sine squared plus cosine squared is 1. So instead of having to rewrite this whole thing, I'm going to put a line through this and just rewrite that that's a 1. So I don't have to rewrite the whole thing. Now I have a fraction divided by a fraction, so I can keep change flip. So I've got 1 over the cosine squared of x, sine of x, times sine squared of x, cosine squared of x, over 1. And what am I left with?
Sine x.
Yep. Sine of x. Y'all might wish that we were back in Algebra 2 identities. These get pretty brutal. Any questions so far? All right, 34. These ones say to combine the fractions and simplify to a multiple of a power of a basic trig function. So it could be like, they say like 3 tangent squared of x could be like your answer, just for like a reference. So 34, 1 over 1 minus sine of x plus 1 over 1 plus sine of x. So if I wanted to get these a common denominator, what would I have to do?
Multiply by 1 plus sine x. And 1 minus sine x.
Yep. And what about the other one? Yep. So it's basically just multiplying each of them by the opposite one's denominator. So 1 plus sine x plus 1 minus sine x over, this is a difference of squares, so it's 1 minus sine squared of x so on top, sine of x is cancel. What's 1 minus sine squared of x? You may have to manipulate an identity that you have.
Cosine squared.
Yep, so this would be 1 over, or not 1, 2 over cosine squared of x. And typically, what is 1 over cosine?
Secant.
Secant. So this is going to be 2 secant squared of x. All right, we're going to do one more and then probably stop because my voice is fading even more now. So, and I feel like that's a good stopping point because we're a little over halfway through this section. There's just a lot of problems in this one. 38, sine of x over 1 minus cosine of x plus 1 minus cosine of x over sine of x. So I need a common denominator. So I'm going to multiply the left one by sine of x. Multiply the one over here by 1 minus cosine of x. So I'm going to go ahead and write this as one fraction because they have a common denominator now. So this is going to be sine squared of x. And then up here, this is not a difference of squares, but this is a what? It's another special type. 3 words. Perfect square trinomial. So this is going to be plus 1 plus, it's the first term times the second term times 2. So, although it's a minus sign. minus 2 cosine of x and then plus cosine squared of x all over I'm gonna leave it split for right now. I'm not gonna multiply it through because sometimes in the end it's better to have it split, and I can always multiply it through at the end if I need to. But sometimes things will cancel, so it just makes it easier to leave it separated. Are we tracking what we did in the top step? Okay. All right, so is there anything in the top that I can combine?
Cosine squared, sine squared as well.
Yep, so I can rewrite this as, it's going to be 1 plus 1, so I'm going to write 2 minus 2 cosine x over sine of x times 1 minus cosine of x. So now on the top, notice both pieces on top have a 2 in them, so I'm going to factor a 2 out. So I have 2 times 1 minus cosine of x over sine of x times 1 minus cosine of x. So now, since this stuff's all being multiplied, I can cancel out the 1 minus cosine of x, and that gives me 2 over the sine of x, which can be rewritten as what?
2 cosecant of x.
Yep, 2 cosecant of x. All right, any questions about any of that so far? All right, I'm going to give you problems for up to where we are right now, because with this stuff, just the more problems that you do, the more familiar you'll become with the identities and being able to use them. The other thing I'm going to say is typically prior to the quiz, which I think is after 5.3, anyways, I usually do an identities cheat sheet quiz. Okay, so like you'll have to write in, or like I give you a sheet and you have to fill in all the identities. Then I will check them, so we'll do that like the day before the quiz, and then you'll get to use them. Now, if you have one wrong, I will fix it. If you just are missing one altogether, I will not give it to you. Okay, so don't wait till the last minute to memorize these identities. You've all had to, well, I don't know about you, Lily, but I know all the rest of them have had to memorize the identities before. So, don't wait till the last minute, right? Like, even there's some of them that I don't always remember until I've been using them again. So just, that's why you'll also have more homework problems with this section than like normal.
I was gonna say, even the math classes in North Carolina are essentially easier for us. Like, we don't have algebra 2 or whatever. It's just called math 1, math 2. And there's like
That's what some of the
honors and
public
stuff.
schools around here do too, at least from
Oh,
what
it's
I've
the
heard.
same.
Yeah. Which I'm always like, there's got to be some name to that math. Like,
There's
what
a
is
lot.
math 1? But, oh my gosh. All right, so tomorrow, juniors are delivering Valentine's, so seniors will be in here. I mean, yeah, anyways. Y'all will be in here tomorrow, but juniors won't be, so we won't finish this section till Friday. All these problems will be due at the same time. So, like, when we finish the section on Friday, like, all of them will be due on Monday. So I wouldn't wait till Friday to do them. Like, I would use the 20 minutes that we have left right now to knock out as many of these as you can.